So one of the things that I'm going to do is get into this cloud9 environment. And so it's similar to the Cloud Shell, like similar to this Cloud Shell, except for it's more designed for long-term work where you're going to build software and you're going to build a solution. So I'm going to go ahead and create a new environment, and we'll call this computer vision. And I think it's a good idea to name your environment as well, especially if you have multiple environments you're working in. We'll say this is for doing computer vision work. And then if you're a student or you're just playing around here, I think the defaults are fine. I would just leave the defaults fine. And what it'll do is it'll create a new EC2 instance for you, and it will use a micro instance, which is 1 gig of RAM, 1 CPU. Now, it also will use the Amazon Linux 2 environment. And this is one of the neat things, is that it'll actually automatically hibernate after 30 minutes, which is really helpful. If you're more advanced, you could also play around with Ubuntu. I would again recommend probably the default here. And then additionally, this is something to be aware of, is if you were going to do a lot of computationally heavy work, you can actually spin up very large machines, like a machine that has 256 gigs of RAM and 64 cores, for example. And because you're only billed by the second, you're able to actually be very efficient in using essentially a supercomputer to do your work. Again, I would recommend just using the free tier for students. It works just fine. And we can go here and we say next step, and then create an environment. So it takes probably 30 seconds or so to spin up this environment. And the big difference between the AWS Cloud9 environment and the AWS Cloud Shell is that the Cloud Shell is more for, I think, doing like ad hoc work, moving things around. This is more for maybe working on a project for 9 months, or working on a full solution, maybe even working with other people in your company or other students in a project. This Cloud9 environment is pretty comprehensive for building solutions on AWS. And in some cases, I'll use an environment and share it with another person, and I'll show you a couple of the things that you can do that allow you to essentially share an environment and co-program or peer program when you're building solutions. So it looks like it's about ready to connect here. Okay, so once you're inside of here, it's similar to Cloud Shell because you get a terminal just like this, and you see this has a terminal here. And if you want, you can do the same thing that we did, which I think is probably a good idea from the very beginning, is that I would recommend first creating a Python virtual environment. So Python 3-m venv tilde/.venv like this. I would recommend doing this, and then I would source it. And in fact, what I would do as well is that I would actually edit the bash RC. So we'll do that. So we'll type in, let's just change this. So I'll type in vim tilde/.bash RC. That would give us the ability to edit the bash shell. And then I can do Shift G, which brings me to the bottom. And notice that they have all kinds of fancy things, like they've edited the prompts. That's what this PS1 variable is. You can change it if you want yourself. But what I'm going to do here is I'm going to add a section that says adding Python virtual environment. Just like this. And then I will just type in source tilde/.venv bin activate. And why am I doing this? Well, the main reason is, and to exit, you do escape WQ and then return. And then I can edit this. And the main reason is, now look, if I click this plus icon and I say new terminal, see, it's now sourced that virtual environment. So now I don't have to worry about every time I do anything, it's all set up. So this is now very, very similar to just the regular AWS Cloud Shell environment, but there's more things that it can do that the other environment cannot do. So for example, it has a GUI built in here. where I can upload images. So again, if I went through here and I said File, Upload Local Files, I could just upload things that I need to work with, maybe source code or images or whatever. Let's go ahead and just try one. So I'm going to say Select, and again, I can grab this Marvel character here, put it in, there we go. And then now that it's in my environments, notice if I do an ls, see it's in the same directory. And then I even can right click. I don't even have to use a terminal now. I can just click rename, and we can just call this maybe Marvel. So from a cloud development environment, this has got a lot of extra features that are really helpful. And the other thing that's nice about Cloud9 is that because it's inside of AWS, the communication will be extremely fast because it's in the same location where you're operating on data, doing things like that. So this is essentially the beginning. Now the next thing that I would do in Cloud9, remember we have this repo here, is if you're going to work on a real project, it's a good idea to check this project out and start to commit code to it. So what I'm going to do is I'm going to select this icon code, and I would always make sure you have SSH selected and copy the path to this repository. So we'll go here, and I'm going to type in git clone space and paste this in. So we'll do this, and then it says, are you sure you want to connect? Yes, we do. Look, it said it can't connect. Now the reason why it can't connect is the first time that you create a new environment, you must create SSH keys and then put the public key inside of the location that is you're pulling from. So to do that, we can again use the shell. So I can type in SSH hyphen keygen -t RSA like this, and this will generate a SSH key. And then to print it out, notice it shows me the location right here. I can just copy this like this, paste it in, and then I can just grab this whole piece of text and I can copy it, and then I can go back to GitHub and I can click on my profile and go to settings and then go to SSH and GPG keys, say new key, paste this in, and we'll just call this Cloud9 computer vision, just like this. Once I do this, it'll ask me to authenticate, which I will. And then if I go back and I just do the up arrow, remember with the shell, you can use up arrow is a great way to save time. And then now I can clone the repo. So now that I've got this repo, if we want to start building some more sophisticated tools, I can start doing this. So I can maybe close this. So what I would do, the first thing when I'm building a tool that does computer vision or command line tools is I create something called a Python scaffolding. And to do that, I create several files. So the files that I like to create would be a make file, also a requirements file, which will store all of our packages, and then also I'll create like a script that will do the computer vision. So this will be like my hello world. So we'll just call it hello to start with, and then I'll also create like a test file so that I can test my code. So basically these four files are probably the most important, and I use the command touch, which just creates an empty file. And notice that I created them all outside of this repo. And see if I say git remote -v, I'm not in a repository, so I need to move those. I should have created them inside the repo. So I'll go ahead and do this. I can just type in mv makefile to computer vision API like that, and then I can move it inside. Now you see that it's inside of here. Same thing, I can move the hello file into the computer vision directory. I can move the test file into the computer vision, and then I can move the requirements file. There we go. So once we've got this set up, I can also just cd into there by typing the cd command. And then notice how this shows up, main. that is something that the virtual environment for Python is able to detect when you're in the Git repository. And we can see Git remote -v. If I type it now, look, it says that that's where I'm pulling from. And then if I say Git branch, it shows that I'm on the main branch, right? And that's why it appears right here. So the next thing that I'm going to do is that I'm going to put in inside of this requirements file the packages that I want to load for my project. So we know that one of them will be Boto3, which would be the API, the SDK for Python. The other one is going to be a linting tool called PyLint, which I use to make sure that the syntax of my code is correct. I also like to use PyTest, which will show me that my code is actually working. And then I also will install Click, which is a command line tool, which allows me to build really powerful command line tools with only a little bit of code. So these are typically 4 libraries when I'm working with AWS that I like to use. And then this makefile, why would you use makefile? It's like a recipe book. So that's why I typically put things inside of a makefile. So what I can do is I'm going to go back here to this repo, but I'm going to open up one more repo and I'm going to look for, I think I have an example of Edge Computer Vision inside of my repositories where I can copy some examples, Edge Computer Vision, and I can just grab this makefile here. This looks pretty good. I can copy some things inside of here. So a lot of times I'll just copy makefiles that I have from before and I just edit it a little bit to make it what I want now. So I can just get rid of this. I don't need that for now. So, but typically what I do is I have a command called install, and this just runs a tool that will install the latest version of the Python installation tool pip. And then I tell it to look at that file, requirements file, right, which has all these packages. So again, the main reason to do this is it's quick, right? It's just a really quick way to install things, because now I just do this. I just say make install like that, and I can even tab complete it as well. Typically, I guess this environment doesn't have good tab completion, but you can type in make install and then it goes through and it installs all my libraries for me that I need. Now the other thing that we can do as well is that I like to also create a like a lint that will double check that my code works. So we have a file called hello here. I can just do that as well, and we can, and these disable, these are just different things that maybe I don't want it to check for. And I think typically the ones that you care about are probably just these are the really verbose warnings, which are recommendations and configuration. I usually disable those. If I go through here and I type in make lint, just like that, we can see that there's nothing in it, so there's no problems with that file. But if I wanted to put a bad variable, like this is wrong, code that doesn't work, notice how it says there's a problem. If I type in make lint, it blows up. It says that there's an issue with it. So it's a good way to just kind of have a feedback loop so that I don't make mistakes here. And then the next thing that we can do once we've got this working would be to now start to build out a little bit of code. And so from before, when we were using the terminal, if you remember, we were able to actually talk to the recognition API. And I think I have an example here. Let's find something where we can see something similar. So this would be a good example. This is just a little snippet of code here that let's go ahead and put this into our like a script just to play around with what's happening. So I import Boto3, I use the recognition client, and then this will detect the labels and it will just print out what responses. I'm going to change this bucket though, because if you remember, we put something inside of this location, which is this bucket, which is AWS ML guide, and we also have a file called Marvel. So let's go ahead and do that. Let's change this to the bucket will be AWS ML guide, like this, ML guide, and then this was marvel.jpg, like this, marvel, like that. There we go. And then I can just run it by typing in Python hello. There we go. So we're able to see that we can detect the labels from this particular image. So this is kind of a hello world script. And the next thing that I would probably do as well is that I would double check that the lint still works right here. So we can just do make lints. And then maybe even I write like a really small test to just have something, and I could just say, you know, from hello import, or I'll just say import hello. We'll just say import hello. And then I could make a really small test that says def test hello. And then basically it won't do anything. It'll just say assert hello. Basically, like, make sure that the script even runs. And if I do make test here, we need to add a test for this in our make file. So I can say Python 3, and we can do this. We can just say test hello, like this. There we go. And we just say like a test pass. So this is kind of a silly test. It all does is import the library or import the module and just make sure there's no problem. But now that I've got testing, linting, I've got installation set up, right? These are the steps here that I could give this to somebody else and they could just type in make all. And this would install it, lint it, test it. And just, we know that there's some level of quality that we can give another person with this code. And so at this point, I would check all of this into the GitHub repo. So to do that, I would type in git status, and it's going to say make file hello, requirements, test hello. Those are the 4 files that I created. We'll go ahead and say git add star. That will add 4. If I say git status again, we see that they're ready to be committed. And now what I'll do is I'll say git commit -m adding basic computer vision project, and then it'll ask me to configure my environment, so I'll go ahead and do that so that it has accurate commit messages. And I think this is a good idea to make sure you do this so that you can get good metrics for what you're doing on your projects and who committed what. And then we'll go ahead and reset this like this, and then I'll go ahead and exit. Now notice that it opens up Nano by default, and that's because in Bash RC, the default editor is set to Nano, but I could change it to Vim if I wanted to. But for now, I'll go ahead and leave this the way it is now, and we'll say, yeah, right. Exit, save it. Yes, we want to save it. There we go, and we'll say git push. And now if I go back to my environment here and I refresh it, we should see that there's files, right? These files are there. Now the next thing that I would recommend before we start to build a more sophisticated tool is that I would go through and go to actions here, this icon, and then I would build up a way of testing my code automatically with GitHub Actions. So I'm going to click on this setup workflow, and then notice that it gives you this kind of basic setup here. And what this will do is it'll run whatever commands I tell it. In this case, I want to tell it to install my code, lint my code, and test my code automatically every time I run it. So to do this, what I will do is that I'm going to again kind of copy a good project that I've got set up that will give me some scaffolding. So maybe GitHub actions PyTest. Here we go. This is a good project. And notice that there's a file here that has an installation, a lint, a test, and even a format as well if I wanted to do that. Let's go ahead and do that. We'll do the whole thing. So we'll go here, and I'm going to go into this file, and I'm going to overwrite it. So again, it says installation, lint, test, format. We'll go ahead and start this commit, and I'll commit this. And what it'll do is if I click back on this actions file, is it will now go through and run all those commands that I ran locally right here, and it will go through and verify them. So what's great about this is that now I have like quality control built in. So this would be something called a DevOps best practice, which is that I'm doing operational best practices. Now notice that there was an issue here with something, and it says that Bodo itself has an issue. So this is actually a good test here, which is that what it's telling us is that because I have in particular Bodo 3 as a library, that the tests don't work the same way remotely as they do locally. And so that might be something for us to fix later. For today, I'm not going to fix it. I'm just going to I'm actually going to go to the I'm going to do a get pull here, and I'm going to fix that one change by telling this GitHub actions file that for now we don't care about that test. We can fix that in the future. We don't care about that one for now. And then also this formatting of the code, we can get rid of that. So just for now, I just want to get a basic syntax check. And now if I go through here and I say git status, we can see that I modified that GitHub actions file, .github actions, git add, .github, commit this, and now this should give us fixing or removing bad tests. And this should get us in the spot where we can now start to build a command line tool next. So if we go back to this project, notice that it will rerun the test again. And now we're able to have a feedback loop where at least we have basic, again, quality control, where it's going to check for a lint and check for installation, which I think is a great idea for any project to set this up, because it'll save you time. There we go. So we got everything working, and look at, we can even do this. You can say create a status badge, and we can copy this, and then we can paste this at the root of our directory, and it'll show other people whether the project is failing or working, which is a pretty good idea, because if you're building a project and it doesn't pass, at least you should know, right, that there's something wrong with it. But this just lets other people know that your project is passing, and people can expect that it'll work if they do the same thing that the build server is actually doing. So yeah, the next thing that we want to do here is that I'm going to build out a small command line tool that will let us interact with any file that works inside of a bucket in AWS. So how do we do this? Well, I'm going to need to change this so that it's more modular. And I think I have an example of this inside of this Edge repo. Let's go ahead and see if we can find one of these here inside of Edge. Here we go. Let's look for a command line tool. And let's see here. Hello, click. This could probably be one. This is similar, but I think that, would it be? Yeah, this looks pretty good. I think this is what we want here. So notice that this file here, we use a library called click, and then it's going to ask for a file location, and then we can give it any file that lives inside of the S3 bucket. So let's go ahead and just kind of base our code off of this example. So I'm going to go back in here, and I'm going to just slightly tweak this code. Let's just paste this in, and we can kind of change this around a little bit. So I think the bucket we can use here, which would be this bucket, like that, and then we can just get rid of the rest of this. So what will happen in this piece of code is that it will import this library called click. It will have a command that asks us to do something. So this code or this tool does label detection, right? That's what our help message will be, and then it'll say we'll call this file. So I need the location, or I need the name of the file in the bucket, and then this will say this is the name of the file, and then this will again use the Boto 3 API here. Now notice that this is just an error message that you get because the click framework is super complicated, and this isn't smart enough to know how to get around it. And so I can do this with that. There's actually a command that you can put inside that will tell it. Well, actually, we can do a make lint, I think. So we can do this. We can say make lint and see what happens. And I believe that it'll say this. You can, and then you can do an ignore. So you can say pylint ignore, and we can look at the help message here for this, and we can see that you can put it like that. You can do this. So you can put an ignore message here so that the editor will ignore that particular error message. There we go. If I do this, this should go away. There we go. So this just means that particular error message is just it doesn't apply for this project, and so I got rid of it. Right, so I just said disable, and then if I go through here and I say make lint here, it should work now, and then it looks like we're ready to go. So let's test this tool out. How do we test out this command line tool? So what I can do is I can say first I'll make it executable. So you type in chmod plus x and then the name of the file. And the reason you do this is that way it can read this. This is the shebang line, and we can actually put in a help message like this. And we can say, okay, here's my tool, and it says this tool does label detection. File, this is the name of the file. And maybe even what I can say is this is the name of the file in the bucket. Maybe make it a little bit more descriptive. There we go. This is the name of the file in the bucket right here. This tool does label detection. So now that I've got this, we can actually do what it says. We put in file, and in particular, we know that file was called marvel.jpg, like that. There we go. And now we're able to print that out, and it shows all the different labels. Now, it's a little bit messy, so we can maybe make this a little bit cleaner here. So there's two things that I think that are issue is that we can potentially kind of clean this up a little bit, because again this is a little bit difficult to read, and so maybe what we can do is actually just write a little bit of code that makes it like print a little bit more nicely. And so there's a couple ways that we could do this. One, the way that I would do this is I would go to the requirements file here, and let's use IPython to experiment with the code. So I'm going to type in IPython and then do make install like this, and then actually recreate what this does by typing in IPython, but then make it a little bit more interactive. So for here, we know that this code is actually, let's see, click option, detect file, that we can first do import Boto3 like this, and then we can make an instance of the client like that. And then I can also do the file, and we'll call this again marvel.jpg like this. And then we can just put this into a piece of code like that. And then it's going to come up with a response. And we know that we can grab labels out, I think. I don't know if it's uppercase or not. Yeah, I think it's uppercase. Response labels. There we go. So at least that's a little bit cleaner if we can grab the labels out. And so maybe what we can do is we can kind of play around with these at the same time. So we can say we can do labels like this, like that. So we could do this. And then what we could say is we could say for label in labels, and then maybe we can print out the label. Let's try that out. So let's open up another terminal here like this, new terminal. And then let's cd into computer vision, and we can even do history. If you type in history, it will show us the commands that we run before. And notice that we can just go through like this and find that file in the history, which is really handy. Or if you're even more efficient, you can type in shift exclamation like this and just put in the number of the command, and then it'll run it again. Aha, so we know that we made a mistake right here. And I should have tested my code by saying make lint, and it will show me that there's a problem. So I should have done this like that. There we go. And now if I do make lint, it should work again. There we go. So I'm going to go through and I'm going to do this command. And look, this is a little bit better. This is a little bit better because we can see that in fact, maybe we can even clean it up a little bit more. And we can say, for example, print, and maybe what we want to do is we want to do name is equal to label name, and then we can also say and that would bring out confidence. Yeah, well, let's go ahead and try this. Let's go ahead and do this, and we can print this out. So at least we're able to figure that out. But we could also do, I think, the name. And then we could also do the confidence. So we could say confidence is equal to label confidence. And then we could say print. And then what we could do, in fact, let's do one more thing. We could say print, and we could do something called f-string. And you can do basically name, colon, confidence like this. So we can make it a little bit confidence like that. And this will make it, I think, what is this saying? Oh, I need to put this into, this is the wrong variable. So it's this and then this. There you go. So basically this should basically pull these out and substitute them. And so now if I put this, we can do this. There we go. So we've got the names and the confidence level. Now we can get even a little bit trickier with this command line tool because Click has something where it can do colors, and that could be really helpful to show people different aspects of what you're building. And so if I go to another project I've got here and I go to my repositories, I think I've got some command line tools I can look at. Let's see, let's look at Click. Here we go, cookbook here. This looks pretty good. And if I look at a file, let's see if we can find some color. Yeah, here we go. So we can add a little bit of color here. Let's add a little bit of this. So at the top of the file, we can do this. We can see, we can add a color that says, for example, detecting labels for, and then we can put the name of the file, right? So we can just say for here, this would be the file that was passed in. And this will make a red label. And then if I again go back to this, we can then make all of these in green here. So we'll go to this and we'll change this from a print to a click echo. And so I just need to grab this piece out and substitute it for right here, like this. There we go. And then we can just get rid of this. So basically this should make like a red top, and then each of the entries will be green. So let's go ahead and try this. There we go. See, detecting labels for Marvel, right? So you can make some very sophisticated computer vision tools like this that can be really helpful in then later building a more complex system. So what I can do now is I'm going to check all this in to, and in fact, what I may even do is put in the, put this into documentation, right? So I could do this. I could just make a little screenshot here like this, and this would show people how to use it. And we'll go through and we'll go back to this issue here, put this into one of the sections. There we go. Grab it, we'll say CLI, like this, CLI, grab that, comment it, go to this, and we'll put this in as some documentation so people can see, you know, basically how to build CLI, just like this. There we go. We'll check that in. And then I can go back here and say get pull. This will pull those changes, just the text I changed from the README file. And then I can say get status, get add these files, committed, adding, working, computer vision tool, and push, just like this. There we go. And then we can again see that this actions here should run again, right? And then we can make sure that our code works. So this is I think one of the best ways to kind of get started with building computer vision tools is to again start with a command line tool so that you can really quickly iterate, right? Because now I could even put different APIs inside, right? I could do celebrity recognition, text detection. Like you can change, right? And this all works. You can change anything you want. This is just the beginning, and it's just this section. You could make a more sophisticated tool that could do all kinds of API calls and even swap out the bucket. Like you could let someone choose the bucket, but really it's the speed. That's why I think command line tools are so powerful.